number 20, question 20. The maximum speed of an aeroplane is 200 kilometers per hour. We're assuming that's still air because the wind determines your max speed, so you can't say for definite my max speed is 200 unless you're talking about still air. So straight away your language would be VPA, the velocity of plane in air and still air, is 200. Okay. Find the maximum speed which it can travel due north if there's a northeast wind blowing at 50 kilometers per hour. A northeast wind. Okay? Now, what we can do here is you want to travel north. So you want to travel straight upwards. Like so. And what you have is a northeast wind blowing behind you. So the northeast wind is sort of adding to your speed. Now, yeah?
That wind is from the northeast.
From the northeast. Excellent. Alright, from the northeast. Yeah, that's grand. That's what you're.
Is that not from the southwest?
Oh, sorry, there is a northeast wind. Sorry, it's not from the northeast, there is a northeast wind. It was said from the southwest, that's the same thing as a northeast wind.
It says from
No, the northeast wind is from the northeast. Okay, so in that case, you're right, it is going southwest. Okay, so what we have here is a problem, okay? The southwest wind, okay, it has two components. Would everybody be happy that it has two components? The two components it has are, it's going 45 degrees. Everybody happy enough with that? Yeah. 45 degrees. We're going to break it up into its two components. Its two components being X and Y. So cos 45 equals x over 50. Sine 45 equals y over 50. Therefore, x equals 50 cos 45 and y equals 50 sine 45. Can somebody tell me what both of them are? They're actually the same thing. We only need to do one of them.
25 root 2.
25 root 2. Okay? So what this means is that the velocity of my air, I'm calling it air this time. Wait. I'm not happy with A purely because planes are often referred to as aeroplanes, so I'm going to turn them into W's. W, velocity of the wind, okay? I sometimes use air and wind. Varies question to question. So this is going to be both of them are negative, right? So minus 25 root 2 I minus 25 root 2 J. I still haven't chosen what to do with my plane. I haven't chosen the direction yet, have I? So technically this here is the speed. It's not actually the velocity because I have no direction to go with it. Okay? So what we're going to do next is we're going to figure out what type of direction we should take. So, what we'll do here is, I can get rid of that now. So what we can do next is, we need to go in a direction that we need to go in such a direction that it combats the wind's direction. Okay, so we want to go straight up. So because we want to go straight up, what we need to do is we need to have a component that goes 25 root 2 I to the right. Is everybody happy with that? That's how fast we're going to the right, because we want to combat the wind part going to the left. Okay? Now what's left is how fast we go straight up. So we can go 200 kilometers an hour. So will somebody do Pythagoras theorem here? We'll figure out what this speed is here. Let's call it n. So 200 squared equals m squared plus 25 root 2 squared. M squared therefore is 200 squared minus 25 root 2 squared. So that and square root it. Anybody know?
199.87.
Okay, sounds good. Is that the square root?
Yeah.
So 199.87.
87.
Can we just double check that one? Okay guys, I know it's just very close to 200. It could be right. I'm just thinking it's very close to 200.
196.85.
Is it 196.85?
Yes.
Who else got 196.85? Okay, so it's looking like that. Did you maybe it's just the maybe just a bracket issue? Uh, 196.85. Okay, it's just too close to 200. 196.85. Okay. Now what we know there is that that being 196.85. So that's how fast we're going north. 196.85. Oh. 196.85. So the velocity of the plane in the wind is therefore going to be, we can get rid of this 200, we can get rid of these straight lines here, and what we're actually going to have is what's it, 25 root 2i plus 196.85j. Okay, so 196.85j, 25 root 2i. Now, here's the problem. There's also a component of the wind that takes away from us going upwards, doesn't it? See the component, it's going southwest. So there's a component that causes us to have to go to the right, and then there's another component that's working directly against our motion. So in order to take all this into account, all we have to do next is just do the actual velocity of the plane. So if you don't know this formula from scratch, it's VPW ends up to be VP minus VW. Therefore the velocity of the plane, VP equals VPW plus VW. Therefore the velocity of the plane is going to be VPW, which is 25 root 2i plus 196.85j, and then that's going to be minus so it's going to be minus 25, oh sorry, we're adding them together because plus VPW. So plus bracket minus 25 root 2i minus 25, oh sorry, yeah, it's grand. So as the effect is grand, right? What we know is that we're going to have to drive slightly to the right, and because the wind is coming against us in a ij direction, we're going to be going slower as a result of it. Therefore the velocity of the plane, two of these guys cancel, and we're going to be left with 196.85 take away 25 root 2. Anybody tell me what it is? 196.85 take away 25 root 2? I'm hoping it's not going to be 0.
No.
Otherwise the plane's going nowhere.
161.
Sorry?
Next one's 1.4.
Once?
Sigma by 1.4.
161.49, okay? And that's J. That's how fast you're actually going up. The plane is going due north as we want. Okay? So what's our maximum speed there for? This here. Now guys, would you be able to go faster if you go if you're going south instead of north? You would be, and can anybody explain why you'd be able to go faster south? You'd be able to go faster south because this component here and this one will be negative, wouldn't it? Because you're going south instead of north. So this one would be negative, and the two of them would add together. So it's easier to go south than it is north. Yes?
When you go from VPW is equal to VP minus VW, why does the VW become a plus if it's on the same side?
Sorry, it's just a switch. So it's like VPW plus VW equals VP, and then I'll just swap it around. So it's done. So two shots in one step. Okay. Alright guys, good with that? Alright, right on. Alright, 22. This is as hard as it'll get for us for the time being. The boat has to travel the shortest route to a point 4.25 kilometers and then return immediately to a starting point at the origin. Okay. The velocity of the water is 8√2I minus 8√2J. And the boat has a speed of 18 kilometers an hour in still water. If AI plus BJ is the velocity of the boat on the outward journey, find A and B at the same time. Find A and B and the time taken for the outward journey, leaving your answer in search form. Find also the time taken for the whole journey. Okay. So, with this one here, what are we doing here? There we go. Alright. You have an XY axis, like so. And you are starting off here from the origin. And the distance you want to cover is 4.25 kilometers directly upwards. So you want to go 4.25J directly upwards. That's what you want to cover. Therefore, your speed has to go directly upwards. Now, problem here being is that you're encountering a river or a current. This current is going diagonal right down. It's going in this direction at 8√2. I to the left. And 8√2 down. Oh wait, no, it's not going left. Sorry, going right, other way. So it's both negative. So actually, it's going. Put it in red. Actually, it's going this direction here. Plus 8√2 I. Thank you. 8√2 and 8√2 down. Okay, so. Long story short, to battle this current, what must you do? If you have a current coming at you this way, and you really want to go straight up, what must you do to go straight up? You have to aim sort of left, don't you? Because the current has a component pushing you to the right and down. So we're going to aim, if it's going right and down, we're going to aim up and left to combat it. Okay? So we've decided that our velocity is going to be up and left. Now, this up and left velocity, we already know a lot about it. We already know that the hypotenuse has to be 18. We already know that to combat the 8√2 going to the right, we must go 8√2 left. And then what we have to figure out is how far to go up. So we're going to use Pythagoras' theorem and find out, we'll call it, I don't know, P, any letter you want. So therefore 18 squared plus, 18 squared equals 8 root 2 squared plus p squared. So somebody can be on the calculator. P squared equals 18 squared minus 8 root 2 squared. Put that in and then square root the answer.
14.
What you get?
14.
14. Nice convenient number. So 14. So we've now figured out what A and B are already, haven't we? We figured out that the velocity of your boat in, is it a river or what is it? Water. Velocity of the boat in water, it can go 18 kilometers an hour, but the direction we're going is minus 8 root 2 I plus 14j. Alright. We know the velocity of the water to be what, guys? 8 root 2 I minus 8 root 2j. Now, find the velocity of the boat. Time taken per, he has to return, so you have to do a return journey as well, okay? Now, can anybody tell me what is velocity of the boat is therefore, it's like the last question, isn't it? It's phi bw plus phi w. Now what is phi bw plus phi w? These two cancel when you add them together. So we're looking at, can you guys do this? 14 minus 8 root 2j. So 14 minus 8 root 2 would be brilliant. Once you get that, let me know.
It's 2.69.
Sorry?
2.69.
3.69.
2.69.
2.69. Okay. So that's 2.69, yeah? Is that right? And it's j going directly upwards. You happy enough with that? 2.69j. Okay. So that's 2.69 going directly upwards. And we're trying to cover 4.25. So it's going to be 4.25 divided by 2.69. And how long does that take? Remember, our answer is in hours. So what do we get? Anybody know?
1.58.
1.58 hours. Okay, going to get rid of all this. 1.58 hours. Okay? That is when we went upwards and we wanted to go straight up and our motion was opposing the current. Would you agree with that? Are we expecting a faster time on the way down or a slower time on the way down? We want a faster time on the way back. So now we're located here and we're wishing to go directly south. Now, as before, this one here is the velocity of the water. Velocity of the water, once again, has two components, 8 root 2 and 8 root 2. To combat the 8 root 2 going right, we have to aim 8 root 2 to the left so that we go directly down. Everybody happy with that? We can go 18 kilometers like last time per hour. Like last time, our component is going to be going 14. It's going to be going 14. So, unlike the last question, the 8 root 2j, the 8 root 2j and the 14j are going to be added together this time around. Okay? So once again, you can go through the whole formality of it. You can go velocity of water is 8 root 2 I minus 8 root 2j. Velocity of boat in water is going to be minus 8 root 2 I minus 14j this time. This time notice that they're both minuses this time. Okay, so they're going to add together. Then finally, the velocity of the boat is phi b plus phi bw. Phi w plus phi bw. Add them together. So what's 14 plus 8 root 2? Decimal form, please. 14 plus 8 root 2. Decimal form.
25.13.
25 point.
21.
What you get?
25.31.
Yeah, that's
25.31.
Okay. 25.31. Be big. Now guys, J. Now, it's safe to say that's gone a lot faster than the other one, isn't it? It's gone considerably faster. So what we're going to do next is we're going to divide 25.31 into 4.25 divided by 25.31, and what do we get? It's going to be like a couple of minutes, so it's going to be nearly
16.8 minutes.
in hours. Just give me in decimals because we have the first one in decimals as well.
0.167.
0.167. Call it 0.17, okay? So 0.17 plus 1.58. What do we get? What do we get? We get 1.75 hours, and as it says in the notes, it's the same thing as 7 over 4 hours. So that's question 22 done. Okay, guys.